I wanted to make a video and talk to you a bit about the Vernier graphical analysis, the software that we've been all using for the past few months, and a main tool throughout your IB journey. So basically, I will try to cover every function of the software that you will be needed to use during those lab reports and essentially your IA next summer, with a few exceptions, as some of you might use some extra functions for specific tasks that will not be covered in this video or for your EE. The Vernier graphical analysis, as you probably have understood, is the software that has been developed by the company who creates most of the sensors that we have in our lab. And the first thing that it allows us to do is it allows us to connect the sensors directly with an interface of our laptop or iPad, allows us to record all the data, and then subsequently we can edit and process and plot all of this data on a specific platform. Now, after you have acquired your data, you may do all your post-processing on any other device, any other program. So could be anything from Google Sheets to maybe Desmos to maybe a programming language that you've been learning, like Python, for instance. You are free to choose whatever tool you want, as long as you're able to deliver what the lab report requires at the end. And you're highly encouraged to use the Vernier graphical analysis because it is a software that we have purchased as a school, and it is quite appropriate for the purposes of the IB physics program, also for chemistry and biology if you're interested. Now, the first thing I want you to do is, after you have successfully downloaded the app for your operating system, let that be Mac, let that be Windows, Linux. I think there is no available option for that, okay, but if you're working on Linux, please switch your operating system for this purpose to Windows, and then you will be able to activate the full license by clicking on the link that I have on your Google Classroom. And that link is important because it will allow you to have access to full features until September 2026, when we're going to renew our subscription. Okay, without it you won't be able to have access to all the features. So please do that, follow that link on Google Classroom after, I repeat, you have downloaded the original app. Now, once you initiate the app on your device, you will have this option. We choose the sensor data collection when we are about to connect the sensor. We choose the data share if we want to share our data, and this applies to the wireless sensors, which right now we don't have that many in our lab. We haven't used any. And the manual entry is what I will do shortly, because I don't have any data and I will add some data manually just for the sake of this video. If you have, and you should have, saved the file of your experiment, you should always be able to upload it by choosing file here and uploading this GMBL type of file, and it will load all your data sets, and this will allow you to do all the post-processing at home. You don't have to do that during the experiment. In the experiment, you focus on the data collection, proper run, proper trials, running your equipment, and then collecting everything and packing up. You don't have to worry about any processing. That happens in the next steps. So I'm gonna choose manual entry just to start entering some data. First thing I'm gonna do is I'm gonna save the file just to give it a name. Okay, so always do that when you start your experiment. I'll give it a file I'm going to replace this one. Okay, yes, I want to replace it. Now, let's talk about the general features. On the left side here, you can see that we have the graph, okay? It's a graph, but very often we want to display multiple graphs at the same time for comparison reasons. And the software allows us, if we click on this button here, it allows us to show maximum 2-3 graphs at the same time. And as you have seen, this could be quite useful when you have, for instance, displacement, velocity and acceleration, and then one goes under the other and you're able to make direct comparisons, okay? So that is quite useful. Keep that in mind. You can switch it to 2 graphs or 1 graph, which I'm going to keep now. You can switch on and off your data table, so you can see your data set 1, 2, 3. Remember, every data set for you means a different run. And then a few extra features. Notes, basically this allows you to take notes during your experiment. For example, I noticed that some of you were naming your data sets, so you can click here and you can rename it to maybe trial 1, or trial 1 meant, you know, like with 20 grams, but you can also take notes here and say trial 1 20G, okay? So instead of changing the name of the data set, which you could do, you can also take some notes here, okay? So you can do it in your notebook, you can do it on your device, or you can already include it in your file, and this is something that you can share with more people and they can see your notes. Could be your teacher, could be your lab mates. So this is for the notes. And then the video refers to the ones who want to upload a video and do a video analysis, for instance, of projectile motion. It goes over there. Now I'm going to switch it off because it slows down the app a lot on my laptop. So these are the features over there, okay? This has to do with some updates and preferences for the app, which we're not going to worry about. This has to do with sharing your data, like via Bluetooth with someone else, like a different laptop. So let's leave that for now. Let me add some data just for fun, okay? So let's say I have X over there, and I'm gonna put these variables here for Y. Okay, as you can see, as I enter the data, immediately I see a graph X versus Y versus Y here. Okay, now the first thing I'm going to do is probably change the name of the axis. Okay, remember, one of the most important things whenever you have graph is name appropriately the axis. So I click over there, name, I'm going to give it time, I'm going to give it unit seconds. Okay, and that's enough for now. And for X I'll do the same, and let's say that these are the values for whatever. Let's say velocity, meters per second. I write it like this, or second to the -1. That's it. Okay, apply. So I got my time and I got my my velocity. Okay, let's not worry about the actual meaning of the numbers, right? If they make sense or not. So I have an X and a Y variable. I have a data set 1. And let's see now what we can do with that. One thing that you are doing in your lab and in many labs is that you are interested in general in the gradient of this graph. And in this case, it looks like a perfect straight line. So what you would do is you would click on the lower left corner, graph options. You go apply curve fit, linear, as you can see, apply. And now this shows you a beautiful linear equation. It gives you the gradient of 2 meters per second, which for us is our acceleration. And then there are other functions that, you know, they could also give you the area under the graph by clicking at view integral, for instance, especially if it's a curve diagram. For instance, you're studying force versus time, and then your force sensor has given you a curved line here, and you want to know the area under it because you're interested in what is the area of a force time graph gives us. Think about it. Correct. It's change in momentum, not momentum, change in momentum or impulse. Yeah, so in that case, it could also calculate the integral the area under the graph, which mathematically, sorry, maybe we're not familiar with it from calculus, the area under a graph is calculated with an integral, which is a concept that you will learn in calculus soon, hopefully. So that gave us the gradient, and that's something that you are doing all the time by choosing which data points you want, okay, and then clicking apply curve fit. That's pretty standard, okay. The other thing that we can do, okay, if I click again here at the graph options, edit graph options, I can give a title, okay. Remember, the graphs need to have enough information for the reader to understand what is actually happening. So I can give a title and say velocity versus time graph for cart 1. Okay, let's say that this refers to cart 1 or whatever. I can change the points to lines or bars, okay, so in this case I'm going to keep the points. I can change the range of the x and the y axis. That's, for me, that's enough now, okay. What else? Yeah, so as you can see, I can click left and with my left click here, and I can basically move the axis so that it actually falls exactly where I want it. So I do have this capacity, and I can do this also up and down in case all of the data don't fit in your viewing window. The next thing is, if you want to flip your axis, you simply click here, like you change the variable that is actually shown here. Okay, so right now I can put velocity, and then on the y-axis I can also click and change that. My velocity now is activated, so I go back to my original graph, and then this is your data set 1. When you have multiple data sets, remember, like 20 runs for instance, you will have all of those one under the other, and you can choose which one to show. You can put multiple in one graph, or you can activate and deactivate them like this. And you can even choose, with the column options, you can choose what type of symbol to use, okay, and that's quite important if you want your graph to actually make sense visually. Always use, if not different symbol and color for every different data set, at least a different color if you use the same shape, so that it's quite clear to the eye which one is which. And then of course you would also want to add a graph legend, okay, that you would explain what each one of those shapes and colors actually look like, okay. But that's how you make your graph, as I said, in a sense beautiful or presentable for a report. Yeah. Now I want to talk about something very important for your lab reports and your IA. How do we include the uncertainties in a graph? And next step, how do we create the minimum and maximum line of best fit, and how do we find the average? So these are the next things I want to cover. Very important for a lab report, and must be included every single time, because it's the whole essence. That's what the reader wants to see at the very end. These lines that allow you to make predictions for the future, or estimations. Let's say now that you want to include your uncertainty for time, okay? We have two options. I'll show you exactly what I mean. First of all, click on these three dots next to time, and then add manual column, okay? You're gonna name it time, error, and then units in seconds, okay? And you're going to add the uncertainty one by one. I'll tell you why we do that. Let's say that the uncertainty is 0.2 seconds for each of our measurements, okay? 0.2. And I'll do the same for velocity. Add manual column, and I say that the uncertainty for, I'm going to call that velocity error, okay, just for me easy to remember, and the units are indeed meters per second. Apply, and I'm going to say that my uncertainty is 0.5, 0.5, and I repeat it. You say, Mr. M, this takes forever. I'll tell you in a second how you can do it faster if you know that your error is consistent for all of your measurements. Now, let's say that you want to include the error bar, as we call it, for the time axis. I want you now to go and click on the time column and then column options. There is this lower part which we ignored earlier. It says show error bars. You click there and now you have two options. You can either add a fixed value, so plus minus, and then it takes the same for all of your time data points. So in this case, it would be easier to say that the fixed value is 0.2. So I could go and type here 0.2, okay? Or I can tell it from which column to choose that from. So I tell it that the error bar for time is going to be taken from the column called time error. And now when you click apply, you can see already that my time variables have taken into account the time error for this. Now, why do we choose the manual entry? Because maybe one of your measurements doesn't have the same exact uncertainty as the other. So maybe this one was not 0.2, but maybe this one was 0.3, and this one might have been 0.1. Okay, so this is what the manual addition allows you to do. Okay, and then you have your uncertainties separated. Okay, so let's change that now back to 0.2 just for the visuals. Okay, I'm going to do the same for velocity. So I'm going to click here, column options, and show error bars. Okay, and click use column value, choose. I'm going to take the velocity, so be careful that you choose the right column. Apply, boom, and now I have my error bars for my graph. And this is a graph that actually makes sense, guys, because remember, doing an experiment in physics and not being aware of our uncertainties makes absolutely no sense. So it's not just about calculating it, but it's also showing it on the graph and how big those uncertainties are. So basically, when you look at this data point, this 1.2, this one basically tells us that we have this box of uncertainty, so around this area, like defined by basically the limits of your error bars, that tells you basically that this data point could actually be falling anywhere inside this box, anywhere. So this is your uncertainty. Okay, that's why this is important for us to also see it visually. Okay, now that we have done that, oh, before that, one more thing. There was an extra option here that said where is it? That said add calculated column. Now this one will allow you to express, for example, let's say I want to take my time and I want to square it. Okay, so I'll say time squared, because maybe that's what you need for your experiment. Okay, and you don't want to do that manually, of course, so you add it there, blah blah blah, insert expression. It's the first time I'm doing that. So do we see somewhere x squared, ABC are parameters you can set, x, y, z are existing columns. Okay, so I'm gonna take time times time. Okay, so this is time squared. Apply, and now I've taken my variables of time and I've squared them. I'm not gonna need them now, but in case you wanted to plot something against times squared, you're able to calculate that nicely from the software with just a few clicks. Now let's do the maximum and minimum line of best fit. So we want to see the line that has the largest possible slope passing through those error bars, and we want to see the line that has the minimum slope passing again through all the error bars. And we have to do that manually, okay? We can't do that directly from the software. I'll tell you why. So we click here and we add, on this button, we click add manual fit now, okay? And we get this beautiful line. Now this line has these features. First of all, over here, we see the information about the gradient and the y-intercept, nothing new. And we have those squares here. Now the one in the middle, if you click on it, it allows you to move the line up and down, up and down. And these two, the one on the bottom part and the one on the upper part, allow you to change and manipulate the gradient. Now, what do we want to achieve? As I said, we want to create manually the maximum line of best fit, the one with the largest possible slope. So all you have to do is make sure that your line is able to pass through the upper left corner of this imaginary box, okay, that is determined by the boundaries of the error bars, okay. So, and again, we don't want to be too strict with this, like down to the millimeter, but also don't want to be like too, on the other side, not calculating it. Okay, so we will try to do it as accurately as possible. So that line should be basically, as I said, touching the corner of that parallelogram over here, okay, and do the same on the other side, over here, maybe. Yeah, so we wanted to make the maximum slope, okay? The maximum slope geometrically would be if this one doesn't go on that part, but it goes on the lower part, okay? So somewhere here, more or less, and that one, okay, let me see what I can do here to see that better. Okay, so you see, if I want to see the data points better, I can go up and down with the left click when this symbol is created here, and I can squeeze in the axis better, okay? So, as I was saying, this part here is kind of touching the edge of that box, and then it crosses through all of the error boxes, the areas of error, and now all I need to do is basically maybe check that one so that maybe it's there, okay. I can make it a bit larger maybe. Okay, that's the maximum I can go, okay, and I'm happy with that. So here I have my value for this is the maximum possible slope of this graph, okay, and this is the y-intercept. And now you want the minimum possible slope. Now the minimum possible slope will be done in a similar way. You add a manual fit, okay, with completely different data, okay, so I can move that up and down. And now you want to do the same, but you want to have the minimum slope geometrically. So I'll do the same thing. I'll try to make sure that my line is also crossing through the further outside corner of my first data point, okay, and now I need to adjust the rest, okay, so bring it down, okay, and then this one somewhere there, and I need to adjust this one again. So now I can go up and down like this, okay, and maybe I have to bring this one down a bit. Okay, so you do have to play with it a bit, okay? So you have to experiment and test it. Yes, and yes, okay? I'm happy with this. So I have my maximum as 2.4 and I have my minimum at 1.6, okay? So I repeat, this is very important for our experiments. We need to know the maximum and minimum range for our slope and the intercept. And we need to show that on our graph. And we're going to need these variables as well. So now you can take this graph or any other graph that you make, and you can make it like a screenshot and copy and paste it on your graphs. Or if you want to make sure that the size of the graph and the quality of the image is consistent throughout your report, then I encourage you to, where is it? Yeah, to do an export, okay? And this will allow you to export your graph as a PNG, as an image, and then you enter that to your lab report, okay? Maybe not necessary for your actual report now, but probably necessary for your final IA, okay? So again, maximum and minimum line of best fit, we need to be able to cross through every area of uncertainty, okay? And we start with a lower one where we're actually touching the outer corner, okay? Kind of, maybe this one could have been a bit lower. I'm gonna change that now. You get the idea. You need to play with it, but don't spend too much time on editing, okay? So as I said, this box and this box allow you to change the slope up and down, and the middle one allows you to move the line up and down until you find the best possible spot. And even the examiners are not gonna measure anything. They will simply look by eye and see if that makes sense or not, if you fall within the right geometrical areas, let's say. And now, as I said, this is the max and the mean, and we want the average. And the average will be nothing else. That's the final thing, by the way, you need to report in your lab report. The average will be nothing different than what you have been doing lately with your errors and uncertainties. So the question now becomes, what is my average line of best fit, including uncertainties for my slope and my y-intercept? And as you can probably figure out by now, you will take your maximum slope and your minimum slope. You're gonna get an average of that. So that will be your average slope. And in terms of uncertainty on that, you want the range divided by 2. Okay, so nothing new. And you do exactly the same for your y-intercept. You do the average between the maximum y-intercept and the minimum y-intercept, and you take your uncertainty on that, as you would do for any other measurements, half the range. And that's how you express at the end in your lab report that my velocity versus time in terms of an equation is going to be this mx, okay? So in this case, it's going to be m, my slope, the average slope, plus minus the uncertainty, and that's going to be times t, because we have time on the x-axis. And then this will be plus the y-intercept, the average value of the y-intercept, okay, in brackets, plus minus the uncertainty of that y-intercept, okay? So that's the idea. If you have questions on that, please reach out to me early on. But the idea is that we're going to show the two lines, like the mean and the max, and then we are going to calculate and show our calculations in our report of the average line of best fit with, I repeat, including the uncertainty on the slope and the uncertainty on the y-intercept, just like we would do for any other data set, and if we had to calculate those uncertainties, okay? And that's all, guys. This is the use of Vernier graphical analysis. This is how you will use it for most of your experiments. It doesn't matter if you will be plotting velocity versus time, force versus mass, force versus acceleration, resistance versus current, temperature versus density, whatever, okay? The idea is always the same. You want the relationship between the y and the x axis with the variables on those axes. You want to have the line of best fit that allows you to find the pattern that your data points are following, and also predict the future, like like a future measurement, like what would it look like at time equals 10 seconds, for example, okay? And that equation at the end of your lab report with the average slope with uncertainty and with the average y-intercept with uncertainty is going to allow you to predict the future. And that's the power. That's why we need that in physics. Very, very important. Otherwise, our experiments, they don't make sense. We want to know our uncertainties, and we want to know if we can predict safely or with what uncertainty the future outcome of an experiment. Okay, so that's what I want to tell you today. I hope this gives you a good foundation to start with. Definitely you will get better to it by doing. Okay, so you have to play, you have to experiment, and you have to do it by yourselves. You have to do it by yourselves, okay, because this is all part of what you will have to do next June and next summer, so you're able to create your lab report. Okay, I hope this was helpful and good use of my time. See you.